Hey there, students. Peter Willett here. Today we're going to take a look at Chapter 2, Section 3. And Section 3 is a very nice short section, because all we're going to look at in this section is how to use your calculator to get answers for trig functions. So calculator approximations of trigonometric function values and of angle measures is what we're going to look at. And this slideshow is only 10 slides long. It's very short. The section of the book is less than 3 pages. So it's very short, really just about getting to use your calculator to do some trig stuff. Now, one of the things I'd like to point out is that in this class, we let students use whatever calculator they want. All of the assignments are done online at some sort of a computer, ideally, so you could use a computer calculator, like your Windows calculator. You could use an online calculator. You can use whatever you want. But because of that freedom, we also have no way of knowing which calculator you're going to use. It looks to me like most of the materials provided by Pearson for this section have to do with using a TI calculator. So I'm going to actually do some demos here for you today using Windows calculator and an online calculator called Desmos, because I think they're a lot better, and then you don't have to go buy a $100 Texas Instrument calculator. In any event, let's go ahead and take a look at what we want to be able to do on a calculator. So the first thing to point out is they give us this cautionary box here, because we've been looking at angle measurements in degree mode, in degrees. And it's also possible to express angles in another kind of measurement unit called radians. And we're going to learn about that and do that in this class. But so far in the class, everything is in degrees. And so we want to know how to use degrees for angles on calculators in order to then get trigonometric function approximations of those angles. And so we have to make sure whichever calculator we're using that it's set into degree mode when doing that work. Now, for example, the way they show that for this class here in the slides is they show these screens from a Texas Instrument calculator, and they enter these angular measurements with a sine function in, and they got this answer. So I'm going to leave the slideshow now. And what I'm doing instead here is I have the Windows calculator I've opened up here on the right, and I have where 2.3 starts in the book here on the left, so I can demonstrate with a different calculator than they're demonstrating with in the slides. Okay, so having said that, this begins on page 182, and we can see there's this same cautionary box here. And they start with the exact same problem that we had in the slides, which is the sine of 49 degrees, 12 minutes. And they do have some examples here on the left, but again, they're using this sort of TI calculator, it looks like, or something like that. So what if I wanted to use this Windows calculator? It's free, it's on every Windows computer. I'm sure Mac has something very similar to this. So the first thing I'll point out is when I just opened the calculator, it came up in standard mode, which doesn't really have any trig functions or anything. To get trig functions, the kind of calculator you need to begin with is called a scientific calculator. A graphing calculator will have trig functions and an ability to graph things. But even a calculator that's like a $10 Walgreens calculator will have trig functions if it's a scientific calculator. So you can change that on the Windows calculator by going over to this menu and then going down and selecting scientific. And you can see there's a graphing calculator too, but let's look at the scientific calculator for now. So then when I click on that, a couple of things to point out. There's this tab here, trigonometry. And if I click on that, then I can get sine, cosine, tan, secant, cosecant, cotan. All my 6 primary trigonometric functions are here and ready to be used. Also, it says DEG. That means it's in degree mode. If I click on this, it switches over to rad, which is for radians, which we will also be doing later in this class. So you could use this when we get to radians as well. But I want to, for now, go to degrees. I click again, I go through something gradient, and then I'm going to go back one more time and I get to degrees. So when this says degree here, then I'm in degree mode. Now, one of the ways to double check that you're in the right mode on your calculator is to take the trigonometric function of a well-known angle. A simple example would be sine of 90 degrees. We know 90 degrees, that the sine is the y value on the unit circle, that should be a 1. So this should work, and I can practice starting to use my calculator with some simple things that I know what they come out to, so I can see that I'm doing it correctly and that I'm in the right mode. So for example, on this Windows calculator, also like a lot of handheld scientific calculators, if I go and hit sine first to try to hit sine of 90 degrees, it's immediately going to take sine of 0. So on this calculator, I have to put in the angle first. So I click in the 90. Then while that's sitting there, I then go in and I click on sine, and it will then apply sine to that angle measurement that I already entered. And now I see that I correctly get a 1, and it even shows above it sine of 90 degrees. So that's how I can do this on this calculator. All right, now let's look at this first problem. So this is even a little trickier than just doing sine of 49 degrees, because they also have 12 minutes here. And this calculator will not do minutes. So we need to convert minutes into degrees as some sort of a decimal. They actually explain that and have a worked example here in the book. Again, this is right at the beginning of 2.3. So it says, we may begin by converting 49 degrees 12 minutes to decimal degrees. And the way they do that is that the 12 minutes, each minute is a 60th of a degree. So if there's 12 of them, that's 12 60ths of a degree. So they make a mixed numeral here. So that's 49 degrees plus there's an additional 12 60ths of a degree. And that ends up simplifying to the decimal of 0.2. So 49.2 degrees. I could do that over here by doing 49. And instead of trying to put in the mixed numeral, I can simply go plus and then do 12 divided by 60. And I get the 49.2. And you can see up here it did 49 plus 12 divided by 60, or 12 60ths, and that produced 49.2. And now that I have that version in degrees of 49 degrees 12 minutes, I can now take the sine of that angle by going to trigonometry and hitting sine, and then I get the answer. So a little bit of a convolution here to first convert these into degrees, then take the sine of that decimal version of the degree angle measurement. But you can still do it on a calculator, and you can see it gives you all the decimals you would ever want for accuracy. And that matches what they had here. Now, having shown you how to do this on a Windows calculator, I'm now actually going to show you how to do this on Desmos, because I think it's a little bit more friendly. So you can just go to Google. I think there's actually a phone app for the Desmos calculator as well, but if I just go to Google and go Desmos, and you see Desmos Scientific, Desmos Graphing. So I'm just going to go to the scientific calculator like we did here. And there is scientific calculator for Desmos, and this is what it looks like. So this is based on a web version, so this is on our website browser. And so the difference here is in the Windows calculator, like many handheld calculators, you type in the angle first, and then you hit sine. Whereas in here, you can just type it in like you would write it on paper, sine of 90 degrees. And so I can see here, for example, that this looks like it's already in degrees, because I see degrees here to double check. So I could also double check by just doing sine of 90. And notice if I just type that in, I just type it in. I don't have to put in the 90 first. And also it immediately tells me this is equal to 1. So if I can just back up, like typing on a typewriter or on your computer screen. And so now if I wanted, for example, to put in the 49 degrees 12 minutes, I could make a parentheses here and then put in my angle to be 49 plus 12 divided by 60, and then close the parentheses. And basically that way I didn't have to do this first, enter it, and produce 49.2 and then take sine of that. I could just put it all in one expression directly. Now, we don't come across 49 degrees, 12 minutes kind of measurements too often, so this isn't something you have to do too frequently, but nonetheless you can do it as quickly here as you certainly could have in the Windows calculator, or any other calculator that doesn't use minutes for an angular measurement. And we got the same answer. Quick and easy. All right, so anyway, you can use anything you want. So here's a couple of options. There's a Windows calculator. Here's the Desmos scientific version of a calculator. And what I will point out is that also there is graphing calculators. We will be looking at graphs a lot in this class. But the graphing calculator on Desmos is particularly friendly, and already we can start to make use of it a little bit. So if I go to Math Tools here, or if I search for the graphing calculator, in this case I can just pull it up under Math Tools. So then we get a big graphing grid, and I can try to use this window on the right the same way I just did on the scientific calculator. But for example, maybe I can check and see if I'm in degree mode. I'm going to go sine of 90. And notice now when I hit sine of 90, it's not giving me a 1. It's giving me something else. That means I'm not in degree mode. So the way I can change that here is there's this little wrench here for the settings. And then if I open that, you can see right down here, it was on radians, and I can just go over here and click degrees. And now it changed that to a 1, and sine of 90 degrees is 1, so now I know I'm in the right mode. Then I could do something similar to what I did previously, just to show. I could do 49 plus 12 over 60, and it will get that same answer that we had over here. So I get all of the ability sort of to use the scientific calculator in these little windows. But even better, because this is a graphing calculator, I can actually type in equations and it'll just immediately graph them for us. Like I could put in y equals x, and it just makes that line. Or what if I wanted to add that that's x squared, and then I get the parabola. So you get graphs so quickly and easily that it really makes it more fun to use graphs to explore math, because it's so easy to make them. Now, additionally, we've been looking at trigonometric functions defined by the x and y coordinates on a unit circle. And if I go under this menu up here, they give me some options for a whole bunch of pre-made graph systems. And one of them here is trigonometry unit circle. So if I click on that, they say, hey, this is what we're going to do, and I'm going to open it. And it automatically puts in some programs and things. But notice we have the unit circle, we have the lines drawn in to show the x and y values, or the little acute right triangle for any particular angle. The angle measurement is here, so they're starting with a 30-degree angle measurement here. And the point is cosine of the angle and sine of the angle, which is how we define those. And I can click on this to even label it. And you can now see, for example, the x and the y value, and that's cosine and sine. So I can see that sine of A, which is 30 degrees, would be 1/2, because that's 0.5. And that the cosine of 30 degrees would be approximated by 0.866. And I can literally scroll the angle around the circle, and the point just translates as I go, showing me the sine and the cosine of all of these angles, from 0 all the way up to 360. Or I could just type in an angle, like what if I put 152? Then it will show me that angle and show me what the sine and the cosine, or the x and the y points would have been, cosine and sine in that order. So there's nice things on the Desmos calculator version. I think it'll be helpful for a lot of folks. Now, having said all that, let's say I'm going to go back to new blank graph. So I just have the calculator there, and let's take a look in the book a little bit further. So we've looked at how you can enter angular measurements for trig functions into Windows calculator, Desmos calculator. And the next thing the book looks at is using the inverse of trigonometric functions to find what the angles would have been. So again, the book's a little ahead of what they're going to do later, because later we will talk about inverse trig functions in great detail. But while we're finding trig functions on your calculator, we want to point out that inverse trig functions are there as well. So what an inverse trig function would do is if you had sine of a theta angle equaled some number, then if you put the inverse trig function on the result, it'll tell you what that angle was in the first place between 0 and 90 degrees. So for example, in this problem A they have here, we know that sine of some angle gave this long decimal, 0.96770915. So what they say is if you use the inverse of the sine function on that result, you can go back and figure out what that angle must have been. And they show the notation for the inverse, like with the f of x inverse notation for a function. You'd put a little -1 superscript up here. They do the same thing on the sine. So this is read sine inverse of that result up there is equal, and then you get this angular measurement of what the theta was in the first place. So theta is equal to that angle in order for sine to give you that answer. That's the sine inverse. So how would we do that on these calculators here? So if I clear this, I would need to first put in the number on this one, 0.9, so 0.96770915. So once I put that number in there, then I want to take the inverse sine of that number. Well, if I go to trig, they don't show me inverse sine, they show me the 6 functions. But if I go second, if I click on second, then it shows me the inverse functions. So then I would click on inverse sine tab of that value, and then it should give me the angle. And 75.399, you can see that's the angle measurement. So we're in degrees, so we know this is a degree measurement, and then it gives me the angle in degrees. Okay, so let's say we wanted to try that over here on the Desmos calculator. Again, I'm going to just do sine of 90 to see if I'm in degrees still or not. I am not, because I gave a fresh calculator, so I'm going to go click on degrees. Now I'm in degrees. Okay, so now I want to do sine inverse. So what I'm going to do now is basically, well, you can bring up a keyboard so I can show you what I did here. You can do it like an exponent and then put a -1 on there, but it will know that that is the inverse notation. And then I would want to put that same funky number they gave us. And if I put that in with the sine inverse, you can see it gives me that same degree measured angle that we had over here. So that's how you do that on the Desmos as well. All right, so Desmos Calculator, Windows Scientific Calculator, any of these will make it so that you can use your calculator to get approximations for sine trigonometric functions of an angle, or to get the angle approximation with an inverse trigonometric function of some result. So whatever calculator you have, or if you haven't gotten one yet, you can use these free ones. I suggest you right away try to find where's the trig functions, where's the inverse trig functions, how do I switch between degree or radian measurements, and then practice doing problems and getting used to technology so that it's at your fingertips whenever you want. A trig value of an angle is easy to get. Keep up the hard work, and I will see you soon.